Hey, what's up? What's going on, everybody? Welcome back to another episode of the Periodic Table. This is the weekly science news show that we do where we, talk about the hottest science news stories of the week. We break them down, and are we experts on any of these topics? No, but that's okay because this is just one big virtual science classroom, and we're all here to learn a little bit more about science together. And I think that's a lot of fun. I'm, of course, your host, Brandon Hanna. I am a mechanical engineer. You might know me as a host formerly over at AfterBuzz TV, the Popcorn Talk Network, or you might also know me from the movie trivia Schmoedown. And if you are watching for the first time, welcome. You're going to see a little bit of different side of me today, and well, it's just a lot of fun. It's a fun show. I'm excited. It's just me and one other amazing host today, so let's waste no more time to introduce him. He's been on the show before. You know him. You love him. He's a streamer. He's a creator. He made Burke made. Okay, that's too many mates for me. My bad. But he's an engineer and camera operator for the Schmoedown Entertainment Network. And now the new FCL League, also a part of this Schmoedown. That's new and very exciting. Watch that over on Twitch. He does a lot of great work there on the technological side of things, making sure everything runs smoothly. It's Dwain Burke.
Hello. How's everybody doing in the internet space? I'm excited to be back here talking some science with my very good friend, Brandon Hanna.
Thank you so much, my very good friend. It's so good to have you here. I feel like I'm rambling on already, so it's definitely going to be one of those types of shows. I've had my morning coffee. I'm ready to go, and we have an amazing show for you all here today. Let's run down our list of topics. A Muon experiment breaks the laws of physics? Not so fast. We're going to talk about it. What is exactly going on there? Could be some major news, could be nothing. We'll find out. Microscopic images reveal the science and the beauty of face mask. So obviously there's a lot of discussion going on in the world of COVID-19 and face mask and how effectively they work. And we're going to talk about different types of fibers and how looking at them at the microscopic level actually shows how effective different mask materials can be. And I think that's pretty cool. And speaking of things that are pretty cool, we do have a special segment for this week, which I am calling, what did you just say? And that is a mysterious X-rays flaring out of Uranus. Yes, you heard that correctly. Or did you? What did I just say? We're going to talk about it. But before we do, let's move back up all the way to the top to our first scientific news story of the day. And it is the Muon experiment that supposedly breaks the laws of physics. So, this is a story. It's in many, many different publications. We chose to go with one from Science Focus BBC. And as always, guys, links to all of the articles that we talk about on the show are in the description down below. The article here starts off by saying, whenever there's big news in the world of physics, most of us react with a curious mix of nerdy excitement and utter bewilderment at the weird, head-spinning details. And that's exactly what happened. Researchers at Fermilab near Chicago announced the results of an experiment suggesting a brand new force of nature that could be in the works. So what exactly is going on here? So an international team of physicists were studying the behavior of short-lived subatomic particles called muons. And this might not be something that anyone is familiar with. We know protons, neutrons, electrons, but there are other particles, subatomic particles at work, muons being one of them. To my understanding, it is a cousin, a relative of the electron, if you will. We'll get into that a little bit more later. But what happened was they sent these muons hurtling around a particle accelerator and watched closely what happened when a magnetic field was applied. And the short explanation is that the muons did not do what they were expected to do. They were more magnetic than they were originally theorized to be as part of the standard model of particle physics. And this is kind of like the best blueprint out there for understanding what they call the building blocks of reality, how we understand physics to act at a subatomic level. The standard model is what we look towards. This is what they used for the Higgs boson discovery back in 2013. Based on the standard model, we knew that the Higgs boson was supposed to exist, but we knew what predictions to make from it, but not until 2013 were we really able to actually observe the Higgs boson and confirm its existence. So it's really cool in that situation where we make a theory and then later do experiments that prove the theory to be accurate. But what happens when you have a theory, you try to prove it to be true, and something happens that you didn't expect? That's kind of what's going on here. So it's a lot to unravel, a lot to dive into. Before I go on any further, Dwain, let's throw it over to you. What were your overall impressions on this article? Did you learn anything new that really stood out to you? Anything that you found to be super pertinent or exciting? And we can talk a little bit more later about what this necessarily means in the scientific community, as far as not jumping to conclusions right away when a potential new discovery is on the horizon.
Yeah, so for me, I actually do have a decent understanding of some of the particle and theoretical physics stuff that was being applied here. And it was just a nice revelation to show how much we still don't know about the world we live in, and we're still trying to discover and understand things more thoroughly. And even now, how much it's still hey, I'm not really sure if I'm right here, so let me just throw some stuff at the wall and see if any of it sticks, which is not exactly how the scientific method works, but in its when you take it all the way down to its essence, that's kind of what it is. And I want to see the equipment that they used to that's what I want to see, is the equipment that they used to do this experiment, because that's got to be some custom stuff. And they didn't have any pictures, which I was annoyed with. I like pictures.
Oh yeah, it's definitely, when you're looking at something on a subatomic level, it's you're definitely going to need some sort of crazy equipment. I immediately think of CERN and the Large Hadron Collider, things of that sort of nature. Things that I, even as a mechanical engineer, someone who loves physics, I don't entirely understand at all. It's not quite my field of study. So this is just as exciting for me to kind of dive into and learn more about because I love physics, right? So I basic stuff, how gravity works, momentum, buoyancy, Archimedes principle, all that stuff, the basic stuff I got down pat. But when you could start talking about stuff on a subatomic level, we've gotten into quantum physics a few times on this show. That is where my understanding of physics kind of goes out the window. So it is really interesting to learn. I had no idea that muons, and I hope I'm pronouncing that correctly, are a thing that existed, but they're essentially the same as electrons, as this article states, apart from the fact that they're heavier than electrons. They got more mass, and they're not new. We've known about them for a while. Apparently, they were first seen in cosmic rays in the upper atmosphere a long time ago in the mid-20th century. So we've known about them for a while, but we've basically known not all that much about them. And even now we're trying to gain a better understanding. And so basically, to get into kind of exactly what happened in this experiment, this article kind of gets into angular momentum, actually, speaking of a physics that I would understand. And all particles, including muons and electrons, have an angular momentum. They're constantly spinning, and that's what gives them their magnetic dipole, which is basically a north and south pole. It's what makes them magnetic. If you think of the Earth and how compasses work and all that. And so they're specifically studying the interactions that with the dipole, and how you characterize them with a magnetic moment. So basically, them spinning, it's kind of think about a moment of inertia and torque and all that type of stuff, to put it in words that most people would try to understand. And so how big the magnetic field is because they're spinning, and basically the magnetic field that they observed does not correlate to the size of what they expect the muon to be, is what I kind of interpreted that as. And so calculating this precisely in the standard model of physics is basically, to my understanding, again, once again in this article, is that that's determining these dipoles is basically how is so fundamental to the standard model of physics, because that is how they did that. They did that initially for electrons, and that kind of proved their theories. It's like one of their benchmarks for just how precise the theory is. They did this with electrons way back in the day, and the experiment proved the theory. But now they're doing it with muons, and the experiment is not proving the theory. They're seeing something they completely didn't expect. And so I know that I'm rambling on here. I wanted to talk about that specifically because I thought that was particularly interesting. And it's kind of like the nuts and bolts of what's going on there. They've done this type of experiment before with electrons in the past. It proved the theory, but now they're doing it with muons, and they're like, hey, wait a minute, this isn't what we were expecting. And it's always super exciting when that happens in the world of science because it means we're learning something new. But I think, looking at this article in particular, looking at other articles on the same topic, there's a lot of information out there right now. A lot of people are just kind of like jumping to conclusions that, oh my God, there's this new thing. It could totally breaks the laws of physics. Like the standard model is broken and we have to start from scratch. And that's not necessarily true. And I thought this would be a really great way of kind of bringing up a topic of conversation of jumping into conclusions in the world of science and how things like this should be handled. So Dwain, I want to throw it back over to you. Did you feel that maybe scientists are kind of like jumping to conclusions a bit here? Do you think maybe we're going to find out later on that, oh, like maybe there was like something a little bit off with the experiment, or maybe there's just something they were just kind of missing looking at the data, and the standard model will actually end up being proven? Or do you think it is possible perhaps that this is some crazy new discovery? And just, I don't know, how soon do you think, like, how long rather do you think scientists should wait before kind of like just like jumping the gun and like publicizing all this information without knowing all of the facts?
I mean, I think you would agree as a scientist or a man of science that the best thing I think would to have someone else conduct the experiment. And if they also reach the same conclusion, then I think at that point you can kind of move forward with, hey, there's something missing from the standard model. Because if this is the only time that this experiment's been done and this is the result that it got, maybe there is something funky with the experiment. Maybe there was a variable that was missed, or a variable that was not calculated correctly. There's hundreds of thousands of things that could have gone wrong with the experiment, that until you replicate the experiment, you can't, really, I don't think you can really draw a definitive conclusion. I do think it is too early to draw a definitive conclusion. But even then, that also doesn't mean that the standard model is completely like, hey, throw it completely out. Like, maybe there's just another variable that we need to introduce, or there's something that isn't being accounted for because we don't know about it yet. And this is the way that we find out about it. Then you adjust the standard model, and then, moving forward, it's no longer broken.
Yeah, well said. I think also this article does bring up, the consequences of the standard model possibly changing, possibly being ruled not as accurate as we thought it to be. And it's kind of like, whoa, like the article basically says, all right, like, calm down, like slow your roll on that, because, the scientific community knows that the standard model isn't 100% the gospel of how physics work on a subatomic level, how these particles fully operate, because it doesn't explain, antimatter and certain other elements of particle physics that we don't understand. So we know that there's more beyond the standard model. And the way they kind of explain that is Newton versus Einstein, right? Newton came along and kind of wrote these like laws of physics and gravity and all that stuff. And then Einstein came along, years later with a much more advanced understanding of physics, and far beyond what Newton had theorized. However, it doesn't disprove Newton, because Newton's laws still work within Einstein's theories. So like the two coexist. So there's only, I think this is kind of going to lead us onto a path of a greater understanding of particle physics that won't disprove the standard model. The standard model will still fit within that understanding, but it'll be expanded. So I think, this is, I just thought really, to reiterate, this was a really good lesson in when there's potentially a new major discovery on the horizon, not to jump to conclusions, not immediately go out there publishing articles saying like the standard model's broken, the laws of physics are completely changed. It's like, oh, slow down, let's sit and think about this for a moment. Science takes a lot of time and diligence, and this is exactly what scientists love, right? Maybe that's why everyone's so excited about it, is because when there's a major discovery that disproves something else, or you can build upon something else, that is game changing. Every scientist wants to be part of a discovery like that. So it is super exciting, but I think we have to kind of temper our expectations just a bit. Understand this is really awesome, this is really fascinating, this could lead to something great, but at the end of the day, let's just take it one step at a time and see how things go. Continue doing experiments, try to replicate the experiments. If many different groups of scientists can replicate the same results, then we know that, okay, we've got something on our hands. We still don't quite understand, right? We don't know why these muons are acting more magnetic than we expect them to act. So now let's kind of get into the why this is happening. So, it was time to just wait and see. And it's fun to, in the meantime, though, to a safe degree, to theorize and speculate what this could possibly mean, right? We could all come up with our own little theories as to why this is happening, and kind of see how it all plays out. And it can lead to a lot of fun discussion, but kind of with a little asterisk. That's would be like, hey guys, this is fun, but let's not jump to any crazy conclusions.
Yeah.
So yeah, really, really, really fascinating stuff, especially if you're a fan of the world of particle physics. And we'll just have to kind of check in on this story and see how it progresses. I think this is going to be a story where we're going to be able to follow it for weeks and weeks to come. And if there are any advancements on it, I'm of course going to bring it back on the show for us to talk about again. Before we move on to our next topic, did you have any more thoughts on this article, this topic in general, Dwayne?
No, I think you put a nice cap on it by just saying to temper the expectations moving forward until we can see if they replicate the same results.
Yeah, for sure. And I know this whole story was kind of like a mouthful, right? I felt myself even kind of rambling on a bit, but there was a lot into it, a lot of really cool, fascinating stuff that I wanted to try my best to understand myself, in addition to trying to explain it in a way for other people to understand, because it took me a few reads for sure. I don't have the best reading comprehension skills, guys. I had to read this a few times to make sure I understood it correctly. So we're all on the same page. It's really fascinating, really exciting, a little bit over our heads, but that's okay, because if we learn just a little bit about it today and a little bit more about it tomorrow, we're just getting more and more educated as the days goes on. And that's what this show is all about, just having an overall better understanding of science and having a little fun while we do it. But before we move on to our next topic, guys, I just want to thank you all for watching. Everybody in the live chat, it's super great to see you all here. We've got Michael Chu, Raul Alejandro Mendoza, Ken Ulozas. I hope I'm pronouncing that correctly. Welcome, Ken. I don't think I've ever seen you in the chat before. Sabrina Ramirez, of course, here as always. Thank you guys so much for being here. Guys, if you're watching, please hit that like button. Subscribe if you like joining us here every week. Hit that little notification bell so you don't miss any topics of discussion in the world of science going on over here. And yeah, leave a comment down below if you're watching after the fact and you want to join in on the discussion. I would absolutely love to hear your thoughts. If you know more, I guarantee you there are many, many people out there that know more about this topic, know more about physics, subatomic particles in general. If I said something wrong, or if you want to just kind of chime in and add a little bit more information depth, I would love that. Trust me, guys, I do this show here every week. I've done, and continuing to work on my film physics videos that I do. And honestly, I do my best to be as accurate as possible, but I would love to be corrected, because it means we're getting a conversation going and it means that we're all learning. So if I say something wrong, feel free to correct me. I think that's great. I will not get offended at all. So, shoot, let's keep this conversation going, and let's all keep on learning. And speaking of which, let's move on to our next topic. We're going to learn something else new today, and it's all about the microscopic world of mask. Microscopic images reveal the science and beauty of face masks. So studying fabrics at a very high magnification helps determine how some face masks filter out particles better than others. And the close-ups reveal an unseen beauty of the mundane objects and that have now become an essential part of our world, right? I mean, I don't know about you guys, but putting on my mask is the same thing. Like I do my 3-point check, like my wallet, car keys, phone, make sure I got my mask on. It's like muscle memory every time I go outside my house to put on my face mask. It's gonna be like weird eventually down the road not wearing our face mask out in public. It's gonna be weird for me. I'm still gonna do it, I think, for quite some time, if out of habit, if nothing else, but of course out of safety as well. But it's really important, I think, out there, especially now we've got the COVID-19 vaccines, basically out in full force pretty soon. It's going to be readily available to every American. And I don't know too much about how vaccinations are going in different parts of the world, but I know here in the United States, I myself am getting close to finally getting my first dose of the vaccine this coming week. So that's exciting for me, but it's important to continue to wear your mask. And I know there's obviously a lot of politics and skepticism out there revolving face masks, but rest assured, the science proves that face masks work. And as it turns out, some work more than others. And this is exactly what this article is doing. Aside from making sure that your mask has a good fit, completely kind of sealed around your face, make sure it's worn correctly over your mouth and your nose, guys. But there is also a microscopic element to different materials. Let's say polyester versus cotton. And there's a little bit to dive in there first. But before I do, Dwayne, I want to throw it back over to you before I continue to ramble on, which I feel like I'm doing a lot today. What were your overall thoughts on this article? Did you learn anything new? Did you potentially realize, like, oh my God, I have a face mask at home that's made out of this material instead of this material. I got to go out and get more of this material because it's a better way of keeping myself and others safe.
I mean, I actually have cotton face masks, so I was like, oh, cool, I made the right choice.
There you go.
But I mean, I didn't really know the microscopic elements of it, but reading the article, it made sense. The fabrics that are a little bit more chaotic in their construction make it more difficult for particles to pass through. The ones that are a little bit more man-made and processed and look a little bit more organized allow for easier pass through of particles. I mean, it makes sense. So I don't know why people are so dead set against it, because it makes sense.
Yeah. No, it certainly does. I think I actually even have a couple images here. Let's throw that up. So that is a microscopic image of cotton fiber. So that looks pretty cool. That looks almost like straw, if you ask me. Like I don't even know, like a wicker basket, which is pretty cool. And then over here, this is an image from the article of a cotton polyester blend, and you can see the difference, like you were just talking about, Dwayne, how the cotton, the way it is wound together, it's very chaotic and kind of fills in a lot of gaps and is kind of all kind of holding itself together, where the polyester is kind of lined up very clean, very precisely. All the strands are kind of parallel to one another. And you can see how it would be easier for something, moisture or microscopic particles of obviously the virus and what else you got going on there can kind of seep their ways through the polyester a little more easily than the cotton. You can kind of visualize it, right? I'm not crazy. So so I think that is pretty cool to see, and it does, like the article says, it does look quite beautiful. But yeah, as you can see, guys, they used a scanning electron microscope, and they examined dozens of materials, including coffee filters, pillowcases, surgical masks, and N95 masks. Last year, the team found that the N95 respirator masks are the most effective at providing protection from aerosols like the ones in COVID-19. And researchers, as we just mentioned, reported that synthetic fibers like chiffon and rayon, they don't trap as many particles as tightly woven cotton flannels. And they've even talked about how cotton traps moisture really well, which also helps both ways. It helps keep you safe, and it also helps keep others safe from you. If you potentially have the virus and don't realize it, if you're wearing a mask, that's kind of the goal. It protects you from spreading the virus to others. So yeah, because cotton, as it says here, cotton loves water, and it swells up in humid environments. And when that swelling of the cotton, as you can imagine, would make it even harder for particles to pass through it if the cotton fibers are all swollen up and all butted up against one another really tight. So it's really cool to see more than just like people saying like, oh, masks work, to actually kind of have an understanding microscopically how everything works and how these masks keep you safe. I thought this was a really interesting article to kind of just go over it and show the science behind face masks, because there is so much misinformation out there. You know, people saying like, originally they told us masks didn't work, now they're saying they do work, and this and that. And it's like, no, like, as you can see here, the science shows that they do work and that some work more than others. And so it's just a matter of finding the right face mask out there that helps keep you safe. And obviously cotton is the way to go, guys. If you've got a polyester mask, you might want to consider changing it to a cotton mask. And if you're fortunate enough to get your hand on some N95 masks, because you know they have been reserving those strictly for healthcare professionals to keep them safe out on the front lines. But if you are lucky enough to have an N95 mask, that's clearly the best one. But you know, that's I just think it was really interesting and really cool. Do you have anything else more to add to this story, Dwayne? Any more thoughts? Anything that piqued your interest?
No, I mean, just get vaccinated if you can and wear your mask. That's really all there is to say about it. Is like, it's the science shows that it works, so just do it.
Definitely. There you guys have it. The science show that it works, so do it. Wear your face mask and make sure it's cotton. So with all that being said, let's move on to our special segment for the week. And I already forgot what I titled it. I titled it, "What did you just say?" Because, I mean, how could you not pick a headline like this? Mysterious X-rays are flaring out of Uranus. For the first time, astronomers have detected mysterious X-rays flaring out of Uranus. Well, how is this happening? According to NASA scientists, Uranus is so massive that it could just be scattering X-rays given off by the sun more than 1 billion miles away, or perhaps the fine rings of dust surrounding Uranus are generating their own radiation through some unknown process. A closer study of Uranus is required to know for sure. So before I get into the rest of this article, Dwayne, I want to throw it back over to you. Did this headline make you laugh? Like, did it make you giggle just a little bit? And if so, was that enough to catch your attention? Like, when you see a headline like this, I mean, you got to like at least skim through it a bit to find out what's going on. Did you find this article interesting in any specific ways? Anything that maybe you learned for the first time while reading this article?
The most interesting thing I found about it was kind of paired with the first article, was again just like discovering things that we don't know, or discovering something and then it only raises more questions than it really answers. Because even though they detected all of these X-rays, they still don't know how it happened. And while they have some ideas, they can't really say that, oh, this is the one that's doing it, because they don't have enough information. Because like I think it said in the article, only one probe has ever gone to Uranus, and then so they've basically been relying on telescopes, which is not, for this particular thing, I think is not exactly the most reliable data.
Yeah, as it says here in the article, NASA's Voyager 2 was the only spacecraft to ever make the voyage to the planet. And so scientists have to mostly rely on telescope observations from Earth. And according to NASA, X-rays are emitted when matter is heated to millions of degrees, like when stars explode or when matter swirls around the edge of a black hole near the speed of light. That sounds crazy. But until recently, X-ray emissions have been detected from every planet in the solar system except Uranus and Neptune. Which, reading this article, it just kind of reminded me, like, we don't, I don't know about you guys, but like in my day-to-day life, I don't necessarily think about all of the planets out there. Obviously, there's a lot of talk about Mars because it's like one of our closest neighbors. It is one that we are constantly sending experiments to. We just landed a rover there recently, as we talked about on this show, and we're now finally getting sound back from Mars. We're getting high definition video back from Mars. Mars is the talk of the town. It's exciting. That's where we want to send humans next, possibly colonize it. So it's easy to kind of forget about our other celestial neighbors out there. And it's like, okay, yeah, like we've seen like really great images and got really great data back about Jupiter, even Jupiter's moons to a certain degree. There's even been probes sent to Venus, and a little bit about Mercury and Saturn. But I was like, dang, I don't really think about Neptune and Uranus all that much. Those planets are really fascinating. What is exactly going on there? They're bright blue. Uranus has these really cool rings, just like Saturn does. And it's like, wow, we really don't know a lot about these planets. And it made me so curious to want to learn more. And like I said, like these X-ray emissions haven't been detected coming from these outermost planets in our solar systems until recently. There was a new study where researchers looked at data taken from Uranus in 2002 and 2017 and saw clear evidence of X-ray emissions in both years. And so several of these emissions had a brightness consistent with solar X-rays being scattered back outward. However, in the 2017 observations, the team detected a possible flare of X-rays where the brightness of emissions around Uranus increased 4 times from one day to the next. And this may be indicative of additional X-ray emission coming out of Uranus instead of like just reflecting what's coming back from the sun. It's too funny to say. It's too ridiculous. But hey, if it makes you listen, if it makes you learn more, then why not? Why not say it? Why not be a little? You gotta play with the words.
What was interesting though is that second possibility for the X-ray emissions has also been observed before in Saturn's rings. So it's interesting that there's 2 possibilities and they're not really sure which one it is because they just don't have accurate enough data to tell us.
Yeah, definitely. And like you said here, it does mention the rings and how charged particles like protons and electrons could be colliding with the planet's rings in a similar way to Saturn's. So that is really fascinating. It's just a cool planet, I think. It's just bright blue. Blue is my favorite color. I don't know if you could tell by all the blue on this show. It's everywhere. I love blue. So immediately I see a blue planet with some rings. I'm like, that's my planet. I want to learn more about that planet. So guys, let us know. Do you want to learn more about these mysterious X-rays flying out of Uranus? It's definitely something you should get checked out. But I think it's really cool. I think it's really cool. I think Dwain, you're really fascinated by it as well, based on the way you're speaking about it. And like you said, this is also kind of like, we reiterate a lot on this show. This is all about how, okay, we got a little bit more data, we got a little bit of answers, but it just poses so many more questions. And at the end of the day, that is just the name of the game when it comes to scientific discoveries. Every time we learn more, we learn how much we don't know. We're like, wow, we learned something new. But in learning something new, we learned how much we don't know about this planet and what exactly is going on. So hopefully, in the not too distant future, we can see more missions to send probes, to send satellites to Uranus and kind of figure out exactly what's going on there. And in the meantime, it seems like we are learning a little bit from telescopes here on Earth, which is really cool. So there are a lot of hypotheses out there, like we talked about with the magnetic fields around the rings and all these different things. So we're just going to have to wait and see. Until then, the X-ray lights of Uranus remain a mystery. So I just think it's cool. Anything else to add, Dwayne?
No, I think you said it enough for all of us.
Yeah. Yeah, no, I mean, you got to giggle just a little bit, but hey, if it gets you learning more about the solar system, then I'm all for it. And I just like giggling at silly things, regardless of educational purposes too. So I'm just like kind of like pretending to care a little bit more about education when I just want to be silly. No, I'm kidding, guys. But hey, all jokes aside, this was a really fun show. Before we wrap things up, Dwayne, anything else you want to say about the topics we discussed here today? Anything about the world of science in general that you wanna talk about?
Just listen to the scientists, and they kind of do know what they're talking about, even though sometimes their theories are wrong. They do know what they're talking about.
Yeah, no, exactly, and that's the fun thing about theories, right? We do have certain theories out there, like the theory of evolution, like the theory of relativity, which have stood the test of time, where scientists for decades and decades and decades have tried to disprove it and have only ended up proving it further in their attempts. That is a theory that stands the test of time, where you can rely on such a theory to kind of like we talked about, be a benchmark for what we understand about the world of science. But sometimes individual groups of scientists can conduct an experiment, come up with a theory, and it's fresh and it's new and it's exciting, but it does take more time to kind of iron out the details. And will it stand the test of time? Will we learn something new about muons from this experiment that 100 years from now, it'll still be proven to be correct? And maybe like in the not too distant future, this will be a fundamental part of our understanding of particle physics and science. But we just have to wait and see. Theories that stand the test of time, like I said, pretty trustworthy, but ones that are fresh and new and exciting, they're the topic of the day. We want to just like kind of like jump on them and hang on them and be like, look at what we found, it's something new and exciting. But it does take some time to kind of sit back, run the experiments, and see how things go, and see if it will be further proven or if it will be eventually disproven. And that's just part of the fun of it all, I think. And like you said, listen to scientists, guys. Listen to sometimes scientists make mistakes, right? There are peer-reviewed scientific journals that get published, and they're not necessarily the most accurate sometimes, but the vast majority of them are. And so it's important, I think, to understand that we're all human. Sometimes humans make mistakes, even scientists, right? Science is all about finding the objective truths in everything. But scientists have their own opinions on these truths, on these objective facts. So sometimes it's easy to kind of fall down a rabbit hole and of conspiracy theories and tinfoil hats. No offense to Ben Goddard out there, he means well. No, he means it in the best way. We're like, let's not create Skynet, guys. Terminator, no joke. But I think it's important to trust the overall scientific community. When the scientific community comes to a consensus about something that stands the test of time, I think we should listen. I think it would be wise to listen to the experts, because people dedicate their lives to this stuff. And it's really important to, like we said, guys, to reiterate every week on this show, get vaccinated if you can. If obviously there are people out there that have certain health problems that prevent them from being able to get vaccinated. So make sure, if you think you might fall into that category, talk to your doctor. Make sure everything is safe. Make sure everything is okay. But if you are safe and able to get vaccinated, I think we all endorse going out and doing it. And if anything, guys, wear your mask. Stay safe. Wash your hands. Practice social distancing, and be responsible out there, because I would love to talk to Dwayne about science in person one of these days on camera. I think that would be a lot of fun. But before we do, that just about wraps up our show here today. Like I said, I hope I didn't ramble too long. I hope I didn't play with my hair too long. I'm having a bad hair day, guys. I know that happens a lot on this show. I'm new to the whole curly hair thing, and I just don't know how to manage it as much as Sabrina tries to teach me. Sometimes it just falls where it wants to fall, and I just can't do a dang thing about it. But I hope you had fun here today, Dwain. If the good people want to find you in between shows, where can they locate you on the internet?
You can find me anywhere and everywhere on the internet at Burke Made, on my YouTube channel on Wednesdays for technical difficulties, and on Fridays for Desertman Live with my co-host Aiden Kosick. And then you can find the FCL broadcasting live on Twitch at twitch.tv/the Schmoedown, Tuesdays at 3 p.m. Pacific every week, with new competitors that are trying to enter the fray of movie trivia.
Awesome, guys. Definitely go check out everything Dwain is doing. He is super, super talented, amazing person, and he deserves your support. And seriously, the technological side of the FCL on Twitch is kind of like blowing my mind how well things have been run over there and how exciting the content is and the show over there. So definitely, guys, if you enjoy movie trivia Schmoedown, if you enjoy movie trivia at all, maybe the Schmoedown wasn't quite your thing, but check out FCL, because it is going to be a little bit different, I think, in a lot of fun and new, exciting ways, and Dwain is a huge part of that. So go check all that out. Support Burke Made wherever they're sold. And I'm, of course, Brandon Hanna. You can find me on Twitter and Instagram at BrandonHanna07. If you're already watching, you've already found my YouTube channel. Please hit that subscribe button and that little notification bell so you don't miss a thing. Hit the like button on this video if you haven't done so already, and consider supporting me on Patreon over at patreon.com/BrandonHanna. I'm gonna start doing like a monthly Patreon live stream hangout, and just hang out with you guys and talk to you about whatever topics of the week. Could be Schmoedown, it could be movies, what have you. And then I also kind of do a monthly show on this channel as well called Brandon Hanna Live, where we kind of like jump outside the world of science. I bring some fun guests on. We talk about stuff going on in movies and pop culture and that sort of thing. So if that'll interest you guys, please, hang out. I like having you all here, and it's super fun and amazing to have your support. And thank you everyone today who was watching live. It means the world to have you here. And so with all that being said, I'm trying to think if I forgot anything. I probably did, but that's okay. I'll bring it up next week if I remember. Thank you guys so much for taking time out of your day for this moment of science.